Yesterday we talked about Scratch, and I introduced some parts of Scratch to you guys, and we kind of just did a slow rollout. The Makey Makey, again, is nothing more than just an extension to the keyboard. It's fancy, it looks super high-end, but all it really is a stripped-down version of a couple of keys on a computer. So if I can create a program that says, when you hit the letter W, do these sets of instructions, then I can use the Makey Makey to do that. And it's nice because now I can create what we call triggers. And triggers are, if this is detected, then do these sets of instructions. And that's what programming is all about, really. If later on when we get into sensors, if a sensor value drops below a certain number, or if a sensor value goes above a certain number, that's a trigger. Do these instructions. So those if statements are what we're kind of focusing on with what we do in coding. That's where I think that elementary students is where you can get a 4th grade, 5th grade, 6th grade student really kind of brought into this idea of how to program. Give them a purpose for programming. It's not just programming to learn programming. It's to take values so you can do an experiment or to create some type of a challenge, which is where we're going this morning. I want to give you guys a challenge, and I want to have you guys like working in group to kind of address this challenge and kind of just experience the way that the same kind of experience, have the same experience that our students did during Camp Blast. So I'll kind of go through some of my things that this is kind of like a staple in my world. These pegboards are perfect. You can buy a big sheet of these, a 4-foot by 8-foot sheet of these, and then just cut them into fourths. And then each student can now have this as like their development board, right? So whatever it is that we do, if there's a need for this, I can create challenges like what we'll do today. And I'm certain once you see how I use these, then you'll start to say, oh, that would work great for this activity that I want to do in my class, whatever. But we went to Home Depot, I believe, and then we asked them, we said, hey, you know, we're doing this for a school camp and this and that. And they donated, or they gave them to us at a fraction of the cost. Plus, normally they charge you to do the cuts. They did the cuts for free and stuff. So they really do work well with education. And so before you go out and spend any of your own money, at least make the effort to, you know, talk to them or have your school site make that first contact with Home Depot or Lowe's. I'm certain you'll get a deal on these kind of things. But here's what we want to do. So my design challenge, I think my computer went to sleep. But my design challenge is one that uses that pegboard. And I'm going to go into the SKMP PD classroom stream. And within that stream, you'll see that it says the pegboard design challenge. Oops, you don't want to see that part of it. It says I'm not done? Oh yeah, right. So on the teacher side, if a student hasn't turned in an assignment, that's what it's about, sure. Okay, so let me roll out this challenge for you guys. So the challenge is one that you're just simply going to create some type of ramp, and you're going to roll a car down the ramp from one side to the other. So you'll need some cardboard. I typically will have like thinner cardboard, but this is what we had available. There might be some additional cardboard laying around somewhere, but scissors are going to be up in front. There's also box cutters. My only discretion is just please be careful with your box cutter. If you want to use the pegboard as your surface and then cut on top of these, they won't affect it if you cut them or you score them a little bit. That'll be fine. But try not to do any kind of cutting on the floor or the tabletops. I don't want to damage any of the school equipment or school materials. So there's this. You'll need to make some type of ramp. That's the initial discussion. But then what I want to do is I want to create a program on Scratch. I want to create a program on Scratch that will then set off triggers. What I really want to know is how long, or like let's just do timing. We can do speed and stuff at a later point. But let's say how long does it take for a car to get from point A to point B on this ramp? So some of the materials that you'll need, of course, is I have these little Hot Wheels cars. I buy a bag of 10 of them for $4 or $5 at Walmart. So there's the Hot Wheels cars. And then you see that these are those pegs. These are like these wooden dowels that you can buy also. We did the same thing when we were at Home Depot. We just asked them to bring some of those or to provide us with those. And they're just balsa wood, and oh, here they go. They sell them in large spindles like this. So if you plan on doing any kind of like experimentation, you can buy them in 3-foot, 4-foot strands, and then just cut them to where they fit. So we'll use these as our little pegboard holders to hold our ramp on them. So you'll start plugging in those, and then you'll put your ramp on there, and you go from there. So that is what you'll need for the experimentation. There's going to be some box cutters and scissors and stuff. I'll leave those laying up on the table too. The way I would hope it would look like is in groups of 3 to 4 more than 3 or 4 means that we just have somebody telling people what to do or sitting off to the side. So you don't want to have more than groups of 3 or 4 as well. So yeah, that's the way it's going to look on there. But before we actually get into this challenge, what I want to do is kind of go into Scratch, make sure we're all in Scratch, and let's just kind of look on how we can create a timer. This is not something that I would just let my kids explore and figure out on their own. It requires some teacher instruction. So if you're in Scratch, go ahead and log into Scratch while I go and log in as well. So I've logged in. I know I've logged into Scratch because my name is in the top corner. It's important for me to make sure my students are logged in, because if they don't log in, they can't save their work, or they can't share their work, and so on. So we'll want to make sure that we're all logged in under your login name, and then just create. We're going to go and create a program. These types of challenges that we do, while we're waiting for the rest of those people to finish logging in, some of those challenges that we do focus around this idea, and this is kind of just the driving philosophy of why I do these types of challenges. There's this engineering design process, and it's integrated into the next generation science standards. So those of you guys that are familiar with the next gen science standards, this is kind of like the newest thing that's coming out. It kind of goes alongside with Common Core. But the next gen science standards have a focus on engineering design, and they really do try to push that. And it's not something that says, here's engineering design standard 1, make sure you do it this year, standard 2. It's more of a thought process that goes along with everything else, and it complements all that you do in your math class, your science class, English. If you do problem-based learning, then chances are you're probably using some elements of engineering design process already. But here's the thing that I want you to kind of think about, and this is really good for my students that are fast learners, or the ones that get those assignments done really quick. You now give them something to go from there, because if they've now been able to begin with, let's define what the problem is. I've given you guys a ramp problem. I want you guys to create a ramp that will be able to initiate a timer and just time how long it takes the car to go down the ramp. Right? That's a simple enough challenge, but there's a lot of openness. I call these messy problems because there really isn't a specific answer to begin with. It's just like, okay, well now you have to learn about timers, you have to learn about the ramp, you have to know how to do all the programming and how to integrate Makey Makey onto this. There's a lot of extra stuff in there that you haven't discovered yet. So when we first develop our problem, then we're going to go in and we look at how to develop the solutions. What types of methods are we going to use to solve this problem? And then once that's done, then we kind of go through this process. But I like this method and the engineering design process. What I really like about it is for my students that will get a project finished and they're kind of sitting there and they're like, okay, I'm done, and everyone else is barely starting. They're just fast learners, so they're really quick. Well, what I like about the engineering design process is it's iterative, which means is that you do the process and then you say, what is it that I can improve upon? How can you make this a better program, or are there extensions to it? And that's what you do, and that's where you're going to get your increased learning from your students, is because they do this process. And then when it's done, then you say, hey, that would be really cool if this happened, or if you added this. I tried to model that yesterday with the group that was doing the obstacle course over here on the side. I then showed them a couple of extra extensions. When they were done, I was like, here's some other things that you can do as well. That's this whole idea. It's just a continuation of a circle. So you're doing the definition of the problem, you're developing, and then you optimize, and you just kind of repeat this process over and over again. That's kind of why you see the double arrows kind of going in the directions. All right, so are we ready to look at Scratch timers? Let me just see from everybody. Thumbs up if you are ready to go at programming. You have Scratch operating. So I need some feedback from some other people with hands not in the air. One way or the other, yes or no? On this side of the room? Okay. So I see that there's a couple of us. We'll just introduce Scratch, and as they're kind of coming in, the people around you can help you kind of get caught up with that. All right. I'm in the Scratch environment. And what I need to start off by saying is, how am I going to get this program to recognize when the timer starts? There should be some type of, trigger that says start taking time. Right. So I will have to create some kind of event that says when this happens, do the rest of these instructions. So I'm looking at my events in the events category, and those events categories right here, see if I can zoom in on it a little bit, is where you keep all of those when this thing start doing. So this is all of those. When I click on it, look, when the green flag is clicked, you guys remember seeing this yesterday, I hope. When the space bar is pressed, when this the sprite is clicked, and so on. We're going to actually use not the green flag today, but when some keyboard is pressed. Remember, we're going to have to use a Makey Makey for this. So when a certain key on the keyboard is pressed, do these instructions. It'll turn on if it detects a space bar or if it detects a right click or something else. So that's what we want to use as our initiation. Now, if you go through and look at some of these other categories, I'm going to kind of zoom in some so you can see them. But there's all of these different options. We need to look, and the nice thing about Scratch is it actually already has a timer built into it. And it is found right here. So there's a timer function. You can drop this into different commands like conditional statements. Before I do anything else, I want to make sure I reset my timer, because if you start it, it takes count 5 seconds, and then you start it again for the next exam. It starts at 6, then 7. So people noticed this with their whack-a-mole game yesterday. You have to reset your variables at the very beginning. So that's what I'm going to do, is I'm going to actually reset the timer. The very first thing that happens when I start this program, as soon as it triggers an event, clear your variables out and start over. Okay, now, let me talk to you a little bit about the way timers are set up. Timer is nothing more than an internal clock that's running inside of your computer. Your computer has a watch running inside of it. It's got an internal clock. Well, the Scratch program accesses that clock, and it just says, start typing time, use that clock. But it doesn't have any place to store the information. It doesn't know where to put the time. So we actually have to create a timer variable and says, read the time and store that value into this timer variable. And the variable is just an open space that says, here's the time running on the computer, store it. Read the time, store it. So we want to make sure that we store our timer into a variable. So we have to actually create a variable called timer. Do you remember where to find the data, potato, patata, right? So let's go into this, data, and click on make a variable. What are we going to call it? Timer. Sounds fine with me. I don't mind timer. You can write down something else, some version of it. All I want to do is create a variable, and we know that if we're specific enough with the details, kids will recognize it and say, okay, that's what I'm looking for. So we'll call it timer with a capital T, I would say. Because there already is a timer kind of command there, so changing it a little would probably make more sense to me. But I'm going off of that. So there's my timer. All right, so let's actually run through a process, because this is what kids will do. Okay, now that I have my timer, I'm going to just say, set the timer. And let's test this program. So what should I do to initiate the program? How do I start or trigger this program? What's going to cause it to trigger? That's what I don't know. So look at the code. What's going to cause this to turn on? The space bar. So let's hit the space bar and see what happens. Let me zoom out. Do you see that I have a timer variable over here off to the side? Okay. It did reset the timer to 0. And then the next code says set timer to 0. So it is doing exactly what I asked. So I'm just kind of walking you through a troubleshooting step. Because kids are going to say, okay, I have a timer set up. I put a variable that says set the timer to 0, but I haven't really done anything with it. I need to take the information that's being ran on the internal computer clock and store it to this timer variable. So in order to do this, I have to take information from the timer that we use, going back into sensing, and find the timer variable. Let's see if I can zoom in for you. The timer variable's down here. I'm going to grab this, and I'm going to drop it into that set timer variable. You see it? The timer is set at 51. Mine was. If you click on it, it'll tell you what the value is right now of timer. It's that internal clock is running. So let me go and find where I'm going to drop it. I need to drop it into this box. Do you see how it highlights? I'm going to drop it into that. And now what I'm saying is, my new variable timer, force it to talk to the internal clock on your computer. So the internal clock on the computer is running, it's taking time, but I need to now say, take that time and drop it into my variable timer, what we named timer. So now what we're doing is we're saying, take this information, put it over here, and then tell me what that time says. So let's run this program one more time. Just hit spacebar again for me. If you look over here on the top of your corner, you'll see the variable timer, and it'll tell you what it gave you. So it's still not doing anything. It's still giving me 0. Even though if I click on this timer value, let me just pull it out. If I click on that timer value, it's now at 2 minutes and 13 seconds. 6 seconds. It's going on. It's 6 seconds, 9 seconds. So why is it not updating when I run the program? Well, what we have to do is create this loop that will say, constantly refresh my timer over and over again, because time changes. It's not going to stay at 1 second. As we speak, the time is changing. So we need to create some kind of instruction that says, refresh my timer over and over again. What do we do? What do we have for that process? We talked about this yesterday. There's a looping pattern. There's a forever. Yeah, so we want to say, forever do this instruction. Repeatedly refresh my time. So I'm going to go and find a forever loop, and I'm going to drop all that information into it. So under control, and if you put this forever loop right there, I'm going to just say, now you don't want to reset the timer, because if you go and repeat that instruction over and over again, it's just going to drop it back to 0 every time. What I want it to do, though, is start the program, reset my timer, and then forever keep track of the time. So if you ran this program, you should be able to watch your time variable on the side. Now we have progress here. Check it out. Oops. I'm going to stay. Do you see your timer resetting, and it's constantly refreshing? And it actually happens in microseconds. You can see 13 seconds, 13 point something. It's all the way up to the thousandths of a second. Not bad. So if you can picture your car, I put my car on my ramp. As soon as I start my timer, it's going to be taking track of time. What am I supposed to do, though? I want to actually know when the car gets to the bottom of the ramp. So I need to do something else to this. When am I going to stop it? When it hits the end of the ramp. So how is the computer going to know when the car gets to the end of the ramp?
Because I'm going to tell it to stop.
It's going to have to sense, yeah.
When the thing gets to
Point A, start timer, drives down the ramp. Point B, stop. So when it gets to point B, stop. Well, the only way I'll be able to know that is if it's consents. The same way it knew to start the timer, I'm going to have to create another condition to say, when it gets to the bottom, stop the timer. So when it gets to the bottom, stop the timer. Let me show you how we can adjust or modify our code to make that happen. So zooming out so you can actually see this. See, it doesn't stop. There's no way I can stop this program right now as it stands. So I'll just turn it off manually. So this forever loop is nice, if you can see where I'm at. The forever loop is nice because it does go on forever, but the issue with this forever loop is it doesn't know when to stop. And I want the car to be able to say, as soon as it gets to the bottom, stop. So I will use a forever loop, but it's going to have to be a conditional forever loop. So if you go over to the side, do you see how it says repeat 10 times? Repeat forever, if then, repeat until. I like this one. So I'm going to change out repeat or forever loop, and I'm going to say repeat until. So let me kind of bring it up. And you may have gotten used to this yesterday with the trackpad. I think it's easier with a mouse, especially for students, to take this forever loop and grab it and kind of move it off to the side. I'm going to replace it with my repeat until. And I'll still drop the timer in. So I'm just replacing and this forever loop you can just toss off to the side. It's gone. All right. So we know that this computer is going to sense when the keyboard is pressed. That's how I know it turns on, resets my timer, and then it's going to repeat. But I need to have a condition that says keep going until something is sensed. So there is an actual section that says, hey, look, when you sense this happening, do this. So let's go to sensing, and let's try and find a block that might work for us. Remember, we're looking for keyboards because the Makey Makey operates on a keyboard. Okay, so the distance to actually looks at the distance on the screen, on that little workspace for the scratch cat. But yeah, you're on the right track. So I'm looking for some type of sensing that will say, if a key on the Makey Makey is pressed, is really what I'm looking at. But the Makey Makey is nothing more than a keyboard. So we're going to use this exact same, yeah, so we're going to use the sensing, that key space, but I don't want to have the key being the same one. I'm actually going to change it to, yeah, I'm going to use a different Variable. What kind of keys are on your Makey Makey? Give me another option. Up, down, left, right. Perfect. Let's use one of those. Up arrow works for me. Okay, so the up arrow is what we chose. The reason why we chose the up arrow is because we need to have two conditions. The space bar turns it on. The up arrow will be what turns it off. So now actually try this. Run your program. Hit the space bar. See what happens. I like the idea of actually making my Scratch cat tell me what I want. So do you see, everyone sees this cat right here in the corner. I can actually have this cat relay the information that is being shown in this little tiny variable. So what we do is we actually want to go and find inside of the purple, which is the looks. If you go into looks, I'll zoom in some so you can see it. Under the looks category, this is anything visual that you want to appear on the screen. So that's kind of what it means. If I click on it, check it out. It says say hello for 2 seconds, say hello in general, think, whatever. You know, and so there's like the show and hide and all these other great options. We're going to just use the say. I don't want to use the say hello for 2 seconds. I don't want it timed because then it's going to disappear. What if my timer goes more than 2 seconds? So I want to just use the standard say on there. So within my loop, I'm going to have him repeatedly say hello. But I don't want it to say hello. What do I actually want my cat to do? The time. So I need to actually input the timer variable into this little block. So where's the data or the timer variable at? Data. And look it, there goes my timer with a capital T. If I grab that and drop it in, I can't grow my trackpad. There it is. Bam. Holy moly, I love to hear that. It's awesome. All right. So now let's reset my program and try it again. So what was your trigger to start your timer? Space bar. So what do you think? We're able to get the cat to say a number. So as cool as Michael Jackson was, seeing him, you know, scream yesterday, and as cool as it was to play Tetris with my Makey Makey, there really is only a certain amount of novelty involved with that, and then it kind of wears off, right? How long can you listen to Michael Jackson scream? I guess I could listen to him forever, I have. But in the purpose of this game, it's a novelty at best. But what if we were able to devise ways where kids can integrate this into the regular curriculum? Using a timer can be a daily thing in class. If you wanted to make this a regular part of your day, kids can store this timer on their own login. And if you want them to do some kind of scientific exploration, you just have them go log in, pull up their timer, and now integrate it to your Makey Makey that's set up in the back of your room somewhere. So you can have this kind of thing using all the time. Now, I like the timer, but what I really want is to collect data. To me, that's the real value of Makey Makey and programming, is to collect the data. I wish there was a way that I could do a trial 1, a trial 2, a trial 3, because that would be really powerful to me, like if I'm doing a science experiment, and even like science fair even. So you guys have kids that are doing science fair, rolling a ball or rolling a car down a ramp, trial 1, store that data for me. Trial 2, store that data for me. I wonder if there was a way to make a list.
Controls.
Okay, so what category would I look for any of that kind of information? If I'm trying to find out how to make a list, where would that make sense to you? What category in those colored categories would it make sense to be found at? The data, right? I'm going to be manipulating data, and I want to make that. So click on the Data tab. So there's make a variable, and then if you go down far enough, it says make a list. So let's make a list. What you're doing is you're creating a new type of variable, except this variable is a list variable. It's like a matrix that will store data from your value that you assign to it. So what I want to do is actually create this timer log. If that's what I called it on my. So let me zoom out. Sorry. When I click on make a list, what is the list name going to be? I'm going to call it timer log. Capital T, capital L, no spaces. No spaces, I talked about this yesterday. Programming convention usually doesn't allow for spaces. The computers don't like that little null space in between the two words. So When you put all the words together and there's no spaces, I like to capitalize one letter, capitalize the other, just to show that they're two actual words. But it's a programming convention. And if you ever look at code from some other people, most of the newer high-end programming languages allow for space, but then they have to go back and fix things, so it ruins the efficiency of a program if you're not working on a very powerful system. So no spaces kills my work. So I'm going to go ahead and now it says, look, all these options popped up from my timer log. I can add something to something, or add something to my timer log. I can delete stuff. I want to add the timer log. So if you're looking at the screen, if you're looking at that screen, you can actually add the timer log to your program. Where would it make the most sense to put the timer log? Inside of the loop or at the end of the loop? I have a great idea. Why don't we test it? Put the timer log inside of the loop and see what happens. And then we'll test it, except there's one problem with this. It says add thing. What thing do we put in there? Yeah, so let's go and take our timer variable, the variable that's right here, the say timer. We're going to take this timer variable and we're going to add this because that's what I want added to my timer log. Remember, this forever loop is repeatedly happening, and it's happening at milliseconds. If you want to kill your computer at a really fast rate, you do something like this where it's just storing these variables over and over again forever. We don't want that to happen. So we want to get rid of that. We want to remove those numbers. So I'll show you how we clear this off in a minute. But let's go and say that was a bad idea, putting the timer log inside of the forever loop. Would you agree? So let's remove the timer log from there. And hopefully it makes a little bit more sense to go on the end, because what I'm doing is I'm repeatedly checking the time. I'm updating my time clock over and over again. As soon as I trigger my second event to stop, then I'm saying, OK, report this number. This is what I want to report out. So there is my timer log at the end. Now, if you hit your program one more time, running it, and then my up arrow stops mine, you'll see that it logs the data under number 214 on my case, whatever yours stopped at. Now, we need to get rid of this. We need to get rid of all these extra data pieces. But go ahead. You had a question? Or were you going to? Yeah, right. I want to clear my data. So there is a way that you can just go in and actually X. But I think that will take you forever, especially if you let it run for 200. So we can actually kind of cheat with some programming code. I can create a forever loop. Or let's see. 217, or 211, I'm sorry, I'm blind. 211 events have been stored under this timer log. If I go and create a forever loop, but have it repeat 211 times, 200, well mine, right? Because whatever your timer log is, you take that number and plug it in. So if you have 7, because you only did it really fast, then put in 7 under your repeat. Now, let's go back to data. I wish there was a command that said delete time log of the last one. Oh, look, delete the last time log. So I'm going to actually just plop that in. And if I double click on this right here, if I just double click on it, it's repeatedly doing that over and over again. It's removing all of those data values for me. Empty, done. So when we are at the point where we have our data list created, we now have our timer set up. What I want you to do before we actually turn you loose with your program, and I think the real focus will be on making your pegboard work and stuff, but let's just for a second think about how I can take this program code and connect it to a Makey Makey. So will you please just talk to your neighbors? I want to kind of walk through the crowd and say, how am I going to get my Makey Makey to do this? In fact, if you want to, take out your Makey Makey and prove that it will work. So think about that for a second. Talk to your neighbors first, and then at some point, connect your Makey Makey, and I want to just walk by and see that you actually have a scratch cat working.
I didn't bring mine, so I didn't.
You have a timer that works. The next step is to just show me that your Makey Makey turns on this timer and turns off this timer.
Well, the light is blinking, but it's not moving.
Touch your ground a little bit better. Your earth. There you go.
Oh, you start.
There it goes.
There we go. Stop.
Nice. What I'm asking now is for us to take this idea of a timer. We've created triggers. You got your Makey Makey set up. What I want to do now is go on to the next piece, which is our design challenge. So we've given you all the programming background you need. This is not something my kids would have been able to discover on their own. I knew I had to scaffold this piece. Agreed? So what I want to do now is assign these, just be careful with them. If you grab them, they're flimsy. They should be okay to move on their own. But when you grab them, just try to grab them, so you're not smacking other people or items. What you could do is set them up against the wall. And I have no direction on which orientation. If you go this, landscape or portrait, it's up to you, however you decide to do. This is your design challenge. So here are the items that you will need to make this work. Your pegboard. Now there's bags of pegs over here, but I'm going to encourage you not to grab the whole bag. Just grab, 5, 6 of them, and then that way other groups can come over here and grab some too. So we're not going to have somebody walk over and hoard the whole thing, right? And no one else can do their project. So just grab 5 or 6 of them. I think 5 or 6 is probably enough. You're going to build a ramp. So what else do I need beside pegboard and pegs? A car. There's plenty of cars up here. I think I have about 9. There's many cars as there are boards. So that would be true. What else? Cardboard. So I have some cardboard set over to the side right there, and it's kind of thick. So if you're somebody that's comfortable using a box cutter, you're more than welcome to. I don't know if my scissors are still in here. They may have been packed up yesterday. Okay, so we'll use a box cutter. And what I recommend doing is laying this out on the floor, on your table, something, and then putting the cardboard on it and then scoring it over this so we don't damage any of the materials here. It's okay if you score these. Okay, so you have that. The box cutters I'll put up on the table. And I think that's it. There's also some tape. There's some tape over here. You're welcome to use painter's tape if you need to attach the cardboard to the pegs or anything. I mean, this is really your design. So if you feel the need for that, it's there. It's available for you as well. Other than that, if you think you might need some additional materials, just come and see me privately. This is a messy problem, whereas that means I'm not giving you all of the directions. I want you to kind of figure out how to make that happen on your own. The largest group that I should see is in size of 4. But I would love to see groups of 3 and 2 even, because that'll give you more chance to do this. But there's only about 9 boards here. So please send your runners up, figure out who's on your team, and then bring your runners up to the front.
There it goes.
And that's what you want. This simulates the track.
Yeah.
And this simulates the car going on and off of it.
All right, so wrap the tape around,
See, there it goes. And then
because that's going to slow it down.
Ramp looks different at this point, and that's okay. There shouldn't be the same standard. That's the open-ended.
Are we going this
That
way
way.
or how are we
Going that way.
going?
We're going that way.
Going that way.
We're trying to see if it hits it, will it, is it ready?
And so when this comes across right there, that should be the trigger to start it.
Do we need to put any of this copper wire on the car?
No, but we need to make it connect to the little earth clamp.
If I roll this car down the ramp and I get 1.2 seconds, and then the second time I roll it down, it takes 3 seconds, that's not an optimal design, is it? We want to make sure that it's reproducible every time. So once you have your physical track working right, then do some data trials and verify that it works.
You want to reinforce it with a little more?
To make a little,
Should I do that? Will that
Yeah.
still let it roll?
Are we started?
yes.
Sweet.
Can we ground that another way other than you?
That's
Are we ready now?
Started.
Yeah.
Stop.
Good. Yes. Good. You guys are off.
Now that one went back to 0.
Got it.
Did it work?
And that time we got, so
one's
first
straight.
time we got 0.49, second time we got 0.53. So if we can duplicate it, which is what we just did,
Okay, come on.
We can get an accurate.
yeah.
Process over product. That's what I'm hoping you're thinking. I do not want you to go over there and when you introduce your there's going to be a gallery walk happening, and if your project didn't, come to a conclusion and you didn't feel like you had a final product that was worth it, do not tell us that you failed. You did not fail. The process and the learning has gone tenfold. I've seen people start with aluminum foil tracks and then say that didn't work. And I've heard great conversation pieces about open circuits, closed circuits, just different things like triggers. You guys are looking at your programming. All of that stuff is the process. And in that regard, looking at it from that side, everybody in here has got some learning done. So you guys are all going to have something to share out. Now, as you're walking from group to group, what I'm hoping happens is everybody as a whole group kind of go to one group, and they'll just do a quick presentation, just saying, here's how we got it to trigger, here's how we got it to end, and maybe something that you want to, just any kind of sharing out that you want to do. Just be very careful with the amount of space that's there, because we're kind of worked in a space. There's a lot of wiring right here. So who wants to be our first group to go? Want to do the share out? I'd love to get one group so we can all kind of congregate in one spot. Okay, so let's do this side first because there's more space in the middle. Can I get everybody to kind of walk towards this direction, and we're going to put our eyes on them?
We connected a wire down to at the bottom of our little car. We have wire down here to start it, and when it goes to the end, it's supposed to stop. That was our third trial of events, from foil to no foil to raised wire, be the top of the car down, and this is our fourth trial, keeping the wire at the bottom.
All right, so we basically have 3 different triggers. This first one is going to trigger some sound effects, and then the start line will be here. And we had a foil on the copper wiring strip, but we realized that wasn't enough connection, so we had to put foil on the bottom too. So the foil will touch the foil, and then same thing down there at the end, the finish line.
Very nice. So very similar to the others, ours is almost identical. We have a start and we have a finish. Those two are connected to the Makey Makey. Starts and it finishes. Our ground was a car. We did have a wire. That little kind of loop was used so that the wire wouldn't interfere or crash with the going down of the car. We got pretty consistent. Our time was like 1.6, 1.7. Obviously, if our slope would have been higher, it would have been faster. You guys understand that? So it's basically our model.
If you're back in your seats, we'll get an opportunity to kind of clean up some of this stuff, but I want to get some feedback from you guys, and I think the conversation that we can have as a whole group might be of some value. Now let me just ask, what kind of things can you see being used from this type of project, or even this specific project, in a 3rd grade, 4th grade? I just want to hear from you, how am I going to be able to integrate this kind of idea into my own classroom? And if you're a 3rd grade teacher, there's got to be 2 other 3rd grade teachers in here that want to know some ideas. So can we just have a whole group share out? What could you do at a 3rd grade level, 4th grade, whatever grade you are in, how can you do this integration in your own classroom?
I teach 7th grade, and we started out with the trash for teachers a year ago. Okay. And we had the kids build their vehicles, and then we have a ramp in our back for handicapped students. So they use that to measure that. And so what we could do now is add the coding to it in your ground and circuitry, and that would make them understand what they were measuring.
Right. So there's this cross-curricular element as well. You have your science and your math being taught in one class. Very cool. What about 3rd grade? 4th grade, some of the younger grades with just measurement and data collection. Is that not an idea for the younger grades, 3rd, 4th, 5? Do you see measurement happening here in this example? So there's definitely measurement. What about data collection? Are we using any kind of methods of data collection here? Okay. 8th graders, where's my 8th grade? Anyone teach 8th grade here? How would this be applied into your class? Do you have an idea of this, maybe some version of this?
She was saying about slope.
Okay.
Graph it, we can change the ramp.
Right. I saw a lot of people using the slope or the ramp like this, which is fine. I never gave you any instruction on this, but what if you were to turn it on this angle? Could you not do different versions of slope as a ratio of rise and run? So if we spaced our pegs out down 3 over 2, down 3 over 2, and then had them calculate things from that, and then changed it, well, what if I change my slope to down 4 over 2? And then say, oh, that's the same as 1/2, down 4 over 2, or same as 2. So there's a lot of different ideas that you can go with here. Having them vary the slopes, varying the size of the ramp, or even just going back to our distance is equal to rate times time, and then using those with different modifications. So the pegboard is nice because, one, you can use it like a ramp if you chose, but you also have these uniform spacing of dots that can then be applied to so much more in there. So you have a lot of, this is one of those items that you can get, have a couple of them in your classroom, and they can go a long way in that regard. So great. What we have planned for after lunch, we're going to stop in a few minutes, and we need to spend some time before lunch and after getting you guys the install of all the software on your computers. We're going to come back and we're going to start looking at the SparkFun, the Arduino board itself. So in order to do that, we have to have you guys install. So I had a couple of people already kind of like learning how to install some of the parts of the program. I would really appreciate if we can get a couple of you guys to kind of like show other people as we're doing those steps, just kind of be the play along, even if you can get the first, the Arduino program environment loaded and some of those other things. But let's just take 2 minutes, 3 minutes, and let's clean up our stations. Any cardboard or pieces that you think you might want to take home with you, great. Other than that, let's just kind of clear up and remove some of these obstacles on the floor. So take some time and clean that up, and then let's start looking at how we can get everything else done.